Hi students, good morning. Welcome to this video session. I remain Samuel Chukwu Emeka as usual. In this video session we shall discuss the study guide for your Model 1 homework. So let's go to my website. Click on my picture to enter the site. Click on mathematics. Click on finite math. And the videos will be in this session. The video that we are doing now will be located in this videos tab. So let's go to the notes. The notes, you see a Model 1 homework study guide. So you click on it. So this is where you will get your study guide for your homework, assignments, and exams. The notes will have the notes, and the videos will have the videos tab will have the videos. Then the resources will be here. The resources, some of the resources, some calculators that are important for this course. Applied finite math. So we shall classify variables as qualitative or quantitative. Then under quantitative variables, we shall further classify them as discrete or continuous. Then we shall also classify variables based on the level of measurement of the variable. We shall differentiate between an observational study and a designed experiment. Then we will list the sampling methods we have and obtain a simple random sample of a specific size. It is highly recommended that you have read your textbook and that you have read the content for the Model 1 as well as use your learning aids. The learning aids on a MATLAB. It is highly recommended that you use those. Then further materials, you have a lot of resources for this course. The prerequisites are these. You view the video on introductory statistics and the notes on introductory statistics, as well as the sampling methods. They are recommended that you do that prior to viewing this video or reading the notes, studying the notes. What in here we discuss, if we talk about statistic, we say that statistic is a numerical summary of a sample. Parameter is a numerical summary of a population. We discussed that in this video under introductory statistics. We discussed that. If you look at the notes, we talked about a statistic and a parameter. We talked about those. So it's recommended you do that. Then if we give an example, like a study from Harvard University researchers found that of 93,600 women aged between 25 and 42, 3 or more servings of berries per week may slash the risk of heart attack by 33%. This is from a Journal of American Heart Association. So what is the 33%? Is it a statistic or a parameter? And then why? So we say that the 33% is a statistic because of the sample. We just sampled only 93,600 women were aged between 25 and 42 were sampled. They didn't, of course, it will be difficult to get all women between 25 and 42. So these researchers just took a sample of those women. That is why the 33% is a statistic, because it is the numerical value of a sample. Another example, number of the letters of the alphabet of Igbo language. I know some of you might ask, what is Igbo language? Well, I speak Igbo language. Yeah, I am Igbo. So this is one of the languages spoken by the Igbo tribe in Nigeria. And what variable is it? So we here, because you can count, we have 36 letters of Igbo alphabet. Just like you have 36 letters of the Igbo language alphabet, just like you have 26 letters in English. So we have 36 in Igbo. This is a quantitative variable because you can count it. You know, it's numerical. Is a number. Then, because you can count it, it's a discrete variable because you can count it. Quantitative variables are classified as either discrete or continuous. If you can count it, it is discrete. If you can measure it, it's continuous. Then, if it is anything quantity, we say it is a quantitative variable. If it's numerical, has a numerical value, it is quantitative variable. Goals scored by Mikel Obi when Chelsea defeated Derby County at the Pride Park Stadium. Yeah, goals, you can count it. How many goals he scored? I think that was a 2-0. So that was the number of goals that we have scored. What variable is it? It's a quantitative variable because it is a numerical measure. Then because you can count it is, you know, they won by 2 goals in that match, is discrete variable. The next one, average amount of rainfall in Nigeria in a year. Can you count rainfall? Can you count rainfall? Or can you count the intensity of earthquake? Can you count it? Can you count snowfall? Can you count it? But it has a numerical value though. You know, it has a numerical value. You know, you might say 32 inches of rainfall, 55 inches of rainfall. So the 55 is a numerical value. So it is a quantitative variable. But can you count it? You do not count it, you measure it. And because you measure it, it is a continuous variable. The next one, the rankings of the likely U.S. presidential candidates. The rankings of, we have a lot of them, right? I think Ted Cruz just declared his ambition. Okay, what level of measurement is this? You know, you can also classify variables based on the level of measurement of the variable. So in this case, we say it's at the ordinal level of measurement because the ranking is important, is relevant. Like assuming they ask you to rank these candidates like in order of who is likely to win. Of course, your rankings are important because it's in order. So the order is relevant. And because the order is relevant, the order of the ranking is important, the order of the ranking is relevant, we say that it is at the ordinal level of measurement. The next example, the volume of water used by Mr. C in a month. What level of measurement it is? What level of measurement is it? So this is at the ratio level when we talk of ratio, and I've done this in the previous video, so, and it's also in your textbook, so it's advised you review those. This is just a study guide. So the volume of water we are talking about is at the ratio level of measurement, because when we talk of ratio level, you have 0 starting point, assuming I decide not to use any water in a month. Any amount of water in a month. Is it possible for someone not to use water in a month? I don't think so. Do you think so? And then number one, it has a 0 starting point, 0 meter cube, 0 liter cube, 0 centimeter cube, 0 liters. I mean, not liter cube, 0 liters if it's United States measurement, unit measurement. 0 cm cube, 0 dm cube. You know, dm cube is liters also. It has a 0 starting point, and then the ratios of the different volumes of water are meaningful. You know, like maybe if I use 2 gallons, if I used 2 gallons yesterday and I used 3 gallons today, you know, the ratios are meaningful. Maybe you might say I used how many times 2 times 3 over 2. You know, I used 1.5 times. The number of gallons I used today is 1.5 times the number of gallons I used yesterday. So the ratios also are meaningful. The next one, an observational study measures the value of the response variable without attempting to influence the value of either the response or explanatory variables. So we talked about the response variable and the explanatory variable. So it's like your when you're talking of your x and y. Okay, we talked about it. Another name you can call the x. So this is the video. The x is the predictor or explanatory variable, and then the y is the response variable. So of course you use we did it here. Independent variable, yeah. In calculus, is the independent variable is the x. The x is the explanatory or predictor, and then the y are dependent variable or the response variables. You predict the response variables based on the predictor or explanatory variables. Okay, so if you don't influence, we want slide. If you don't influence the value of either the response or explanatory variables without attempting to influence those values, we call it an observational study. Then a designed experiment is when you are trying to you intentionally change the value of the x, and then you find how it changes the y. You know, intentionally changing the value of an explanatory variable, which is the x, or you can call it the input and y the output, and then finding the output y. So you see the difference here. One is not attempting to influence the response, the y or the x, and the other one is that you intentionally change the x to know what the y will be. Then we also say that a designed experiment allows the researcher to claim causation between an explanatory variable and a response variable. Okay. Let's look at an example of a designed experiment. You want to research on how on the importance of breast milk. You know, I don't know why some women would not want to breastfeed their babies, but you know, I'm not gonna go into it. But research tells us, if you look at this question, the study involved 234 infants who were divided into 3 groups. One group was exclusively breastfed for the first 4 months of life. Infants in the other 2 groups were randomly assigned to receive either a low protein formula or a high protein formula. When the infants were 15 days old, the levels of the hormone insulin in their blood was measured. And you know, if you read down this research on life science, you know, if I had to paste it, it would be a lot. It tells you like the importance of breastfeeding. Is this study an observational study, or is it a designed experiment? Well, you want to research on the importance of breast milk over the formula, the protein formula. So you intentionally manipulate the eggs. You give some infants breast milk. You know, the mothers breastfed their infants. That is one group, and the other group, rather than the mothers breastfeeding them, they were given a protein formula, and then you now determine the response. You measure several characteristics in order to prove your research. So this is a designed experiment. When conducting a cluster sample, it is better to have fewer clusters with more individuals when the clusters are heterogeneous. Of course, when we talk of clusters, because clusters represent the population, it is good to have as many individuals in each cluster. To determine the yield of his orchard, a farmer divides his orchard into 50 subsections, randomly selects 4, and samples all the trees within the 4 subsections. What type of sampling is this? This is a clustered sampling, of course. When he divides it and just randomly selects 4, but those 4 he selected, he makes sure that he will sample every trees within those 4. So, and if you look at the previous question, you know, it is better to have fewer clusters. But when you have fewer clusters, you want in each cluster individuals that are more individuals. You know, you have a lot of individuals so that you could, because in each cluster you will have to sample all those individuals in that cluster. So fewer clusters with more individuals when clusters are heterogeneous. So this is cluster sampling because all the trees within the randomly selected 4 subsections were sampled. Next one, when obtaining a stratified sample, okay, of course you have to separate the population into strata and then obtain a simple random sample from each stratum. In this case, the individuals within each stratum must be homogeneous. So please read further on stratified sampling. Students at the Southern New Hampshire University were asked to pick 3 songs from a list of 9 free songs available for download. The songs are labeled Song 1, Song 2, Song 3, Song 4, Song 5, Song 6, Song 7, and Song 7, Song 8, and Song 9. This example was done in the video on a sampling method, simple random sampling. I did this example there. What ways can they pick these songs in order to produce a simple random sample? So they can pretty much do it like 3 ways. The first way, they can, you know, list each song on a separate piece of paper, you know, place them all in a hat and then pick 3. List and pick. We call it list and pick. That is one way you can, you know, obtain a simple random sample. Another way you can do that is you can use a table of random numbers to produce because it is 9 songs. Okay, so you have from 1 through 9. You have from 1 through 9. So, and you have to select 3 songs. You want to just randomly select 3 songs. So what you can do is you use the table of random numbers, or what we call random number table, and produce 3 different 1-digit numbers because it is 1 through 9, so it's a single digit. You produce different 3 different 1-digit numbers corresponding to the songs. So let's do an example of the second way. Assuming we have a portion of the random number table 51111 51111 60678 09822. This is a portion from the table of random numbers. Beginning from the left and taking the first 3 numbers between 1 and 9, what 3 songs would be selected from the numbered list? So we begin from here. Okay, this is 5, first one, and we will take first 3 numbers between 1 and 9. Okay, so 5 will select song 5. 1 will select song 1. This is 111. We cannot, if we select song 1, that is it. You know, this is like a case of without replacement. We don't replace what we've selected. So then we 111 with, you know, I mean, we don't need to do 111. Just the first 3 numbers 511. So 5, song 5, we got it. Song 1, song 1, we got it. This one we won't repeat it, so we skip it. Then we come to this 6, song 6. So the 3 songs we shall select are song 5, song 1, and song 6. Another way you can do this is you can use technology to produce the random numbers. I did this in the video, so you can view the video. I used Excel, Microsoft Excel, to do that, so you can view that. So you can use technology to produce the random numbers, and then from there you select. Next question. The manager of Samdom Apartments has a list of the names of 438 residents living in the east wing of the main apartment, and they intend to conduct an opinion survey of resident services. What ways can this be done in order to obtain a simple random sample of 5 residents? Obtain this sample. So first way, you can list all the names. That's a Herculean task. You list all the names of the 438 residents, list all their names on a piece of paper. That's too much work, right? But well, you can just print it out, you know, because you print it out and then you might cut it with a scissors. With the scissors, you cut the names, individual names, with a scissors. And it, you know, that's now on, when you cut it, it's now on different pieces of paper. You know, fold it just like you do for raffle. You know, you fold it and you pick 5. Close your eyes and pick 5. That's a simple random sample, okay, of 5 residents. You can do that. Or another way you can do it is you number the names from 1 to 438. You know, resident 1 will be number 1. Resident, you know, like their names. Maybe Samuel Chukwemeka will be resident 1. Samuel Dominic will be resident 2. Resident number 2. Dominic Chukwemeka will be resident number 3. So you can number all these names. Of course, do that in alphabetical order. Number the names. And use the table of random numbers to pick. You know, now this is 438. So this is 3 digits. 438 is 3 digits. So you use a table of random numbers and you produce 5 different 3-digit numbers. So let's see how we can do this with table of random numbers. We have sample of, portion of random number table here, the portion. And we have to begin, top down approach. We start with this column, we go down, we go down. So we are looking for the first 3 digits. That is what we are interested in, first 3 digits. If we look at 796, 796 is more than 438. You have numbered these residents. The lowest number is number 1, resident number 1, and the highest number is resident number 438. So 796 is greater than 438. So it's not, it's not gonna work. You can't do anything with it. The next one, 319, is less than 438. So you pick that. 648 is greater than 438. No, it won't work. 992 will not work because it is greater than 438. 421 is less than 438. It's in. 291. I'm in. 269. I'm in. 429. I'm in. We only have to pick 5 residents because the question says simple random sample of 5 residents. So let's not 796, I'm out. 319, I'm in. 648, I'm out. 992, I'm out. 421, I'm in. So that is 291, I'm in. 269, I'm in. So that is 4 residents now, okay? Then 429, I am in. Present. Okay, so when you do that, you have 319, 421, 291, 269, 429. Or you say, I'm here. Okay, so this will be the numbers corresponding. This will be the simple random sample of 5 residents. You get resident number 319. I'm here. Resident number 421. Here. Resident number 291. Here. Resident number 269. My name. Resident number 429. Yes, sir. Okay, so this is how you get the sample, the simple random sample of 5 residents. And this is the references and reference websites. Okay. Thank you so much for listening. Please watch out for other videos and notes. And you have a great